Hi, it's Kevin Ryan again.
Hi, everybody.
So, I've been asked to make these videos for your class, and this is section 5.1, and we are going to be talking about polynomial functions and their graphic behaviors. So we're going to start with part one here. Here's a generic polynomial, and you can see it's an nth degree, that's nth, nth degree polynomial. And we try to write it in what's called descending order. So the largest exponent is first, and we call this an nth degree polynomial based on that. And we're going to first explore what happens when x goes to infinity or negative infinity. And there are four scenarios as we're looking at this. If the lead coefficient is positive and n is even, it's going to start up and end up. So it's going to come down and it's going to do whatever and then end up going up. Same scenario, if the lead coefficient is negative, it's exactly the opposite. Everything kind of flips down. And so things are coming from negative infinity, they come up and they do whatever, and then they end up down. With the odd, it's exactly the opposite. It starts negative, it does whatever in between, but ends up. And when the lead coefficient is negative with an odd degree, it starts up, goes down, does whatever, and ends down. So this is typical behavior of these polynomials. And so here are some basic polynomials as we're looking at this. And these are all just the basic monomials. So here's a straight line. You can see it's in slope-intercept form. The slope is 1, the y-intercept is 0, and you can see it just starts down, like here, and ends up. This one here. This one is typical, this one. It's a parabola, right? It starts up, ends up. This one here is going to be the cubic, where it comes up. And then fourth power both up, fifth power down then up, and sixth power and so on. So you can see it's modeling that, and you can take a look at these notes and sort of make the comparison yourself. We're going to move on to part two, and we're going to talk about multiplicity and their zeros. That brings us to here. And again, this is just a straight line with a y-intercept at 1. You can see it's crossing at 1. And it goes up 1 and over 1, and we have a straight line. So here's the behavior. Here the zeros are at -1 and at +1. So if you set this whole thing equal to 0, you could see that's a difference of squares. You could factor it x minus 1, x plus 1, solve it, and you end up it's crossing at -1 and +1. Here, once again, we could factor an x out, which means that you'll get a 0 here. And then you'll get x times x squared minus 1, which again factors into -1 and +1, and so on. So these are just some examples on what to do with this. And there's three different ways that we can kind of view this, so we'll take this here. If we set this equation equal to 0, we solve it and we get x equals 3 equals that makes that 0, 4 and 5 make that 0. If we want the zeros, and we're going to use this expression, the zeros mean where does y equal 0. So f of x basically is equal to 0 here. We get the same answers. And another way to view it is as x-intercepts. So x-intercepts means when y equals 0. And once again, y equals 0. So when that equals 0, we end up with the points here. And you can see the 3, 4, 5 is the same with all of them because these three expressions all mean basically the same thing. Here we sort it as a point when y literally equals 0. So there's your 0 for y. Next up, we're going to find a polynomial with zeros, specifically at 0, 5, and 3, and I want to show you how we got this. X equals 0 is obvious, but here it's -5, but it's +5 here. And the reason is because when I say when x equals 5, to make it a 0, I have to subtract a 5 to both sides, which makes it x minus 5 equals 0. So there's your x minus 5 there. Same with the -3 becomes +3, you add the 3 to both sides to get that. So here's how you would create a polynomial based on the zeros as you do that. You'll probably have homework problems just like that. Let's talk about multiplicity. Multiplicity means that the exponent maybe is something other than 1. So here the multiplicity is just 1, x equals 0. Here the multiplicity is 3. Now that's going to affect whether it crosses the graph or whether it bounces off of the graph, and also if it does cross the graph, how it crosses the graph. So let's start with the first one. Here's the actual graph here. X equals 0 is right there, and you can see it's right there. It's just crossing straight through. So when the multiplicity is odd, it's just going to cross through. At -2, back here. It's going to cross, but it's not going to just cross like this one did. It's going to kind of snake through, kind of like the x cubed that we had on this previous one. You can see it's kind of snaking through. It's not a straight line through like it was over here. So you can see at -2, it's sort of doing its kind of snake thing through as it does this. When x equals 1, it's to the 4th power. And here's 1. 4th power, it's even. This means it's kind of behaving like a parabola. It's literally going to bounce off of the x-axis. And you can see as it comes down, it bounces off the x-axis. Almost like a mini little parabola right there. And back here at -7, it does the same thing. It comes through and it literally bounces off like a little mini parabola right there. And that's going to be typical of these multiplicities. So in summary, an odd multiplicity means that it's going to cross the x-axis, albeit snaking through or straight through like it was here. And even multiplicity, it's going to bounce off. So let's do a few of these graphs as we're looking at this. So we have x equals 0, multiplicity 1. So at 0, it's literally just going to go straight through. And by the way, we can see the degree of this is 1, 2, 3, 4, 5, 6. So you can see it's a 6-degree polynomial, and it's ending up because the a here is positive. If you remember the first one here, when a is positive and it's an even exponent, they both end up. And you can see this result here, they're both ending up. But what happens in between is a little bit more important. So multiplicity 1, it just goes straight through. At -3, it's a multiplicity of 2. And so it literally is going to bounce off. Again, we have our little mini parabola right here. And at 5, it's going to cross through, and you can see, again, it's kind of snaking its way through, kind of like that x cubed from the first sheet once again. You can kind of see that snaking through as we look at that. Next up. Here, our a is negative, so we can see when a is negative, and we have a 4, 5, 6, 7th degree. So when the lead coefficient is negative and it's an odd number, you can see we have here it's going to start up and end down. And you can see that's exactly what's happening here. It's starting up and ending down. And we're going to explore what happens in between. So at -1, it's just going to cross through normal because it's just multiplicity 1. Here at 1/2, multiplicity 2, so at 1/2 here, we get a bounce. So again, here we have sort of an upside down parabola as we're looking at it. And out here at -5, from here, 4th power, it's going to be actually a little over-exaggerated down here. It's going to almost flatten out as it comes out. So 6th power would really flatten out as it comes around. But you can see, again, it's bouncing off there. For our 4th example here, the lead coefficient is negative again, and it's odd. And you can see, again, it's starting up and ending down. And so let's see what's happening in between. Well, it's looking to me like the zeros are at -4. This is just the leading term. At -4, we're here. And you can see it's to the 4th power, so again, it's going to bounce. So we need to know that the behavior is, because it's a 9th degree, it's starting up, and it's going to bounce like this. At 3, it's a squared, so it's doing this, and it's going to literally bounce off like a parabola once again here. And out here at 7, it's kind of snaking its way through again. And you can kind of see, again, that snake, like what I'm talking about. So let's talk about the signs. So if we have signs like this, and we have zeros at -9, 3, and 7, here we have -9, 3, and 7, we don't know the degree of this, but it says that it starts positive. So positive means it's above the x-axis. And after 9, it's also above the x-axis. So we know we're getting a bounce here. So that's going to be a multiplicity that's even in this case. So it goes from positive to negative, so positive to negative at 3. So we know that that's going to be an odd multiplicity. So maybe it's 1, maybe it's 3, 5, we don't know. And then it goes from negative to positive at 7. And so we can see it's just cutting through. Again, we don't know if it's multiplicity 3, so we might get a little bit more of a snake action there, or what's going on. So here we're going to have degree 0. We have zeros at -2, 0, and 4, degree 3. So the 0 at 0 is just x by itself. Here we have x plus 2. Again, remember, when x equals negative 2, I have to add 2 to both sides to get x plus 2 to equal 0. So we can kind of see where the plus 2 is coming from. Same here. This is x positive 4, which means we're going to get a minus 4. Here we're going to have a 0 at negative 2. It says multiplicity 3, so again, adding it to the other side, we get x plus 2 to the third, because it's multiplicity 3. And we have one at 1, multiplicity 1. And it's a 4th degree, and you can see 1, 2, 3, 4th degree. For our last one here, we're going to find a polynomial that could form the graph shown below. So we have zeros here at negative 2, 0, and 3. We can see it's going straight through negative 2, so it's just x plus 2. Remember, it's the opposite sign for the same reason up here. It cuts through 0. Doesn't look like it's doing anything fancy, so over here. Here, it's bouncing up. Again, we have that parabola-looking piece there. And so at 3, it's going to be x minus 3. Again, it's opposite sign with multiplicity 2. We could have said 4. It doesn't change anything. Had it told us the degree, this would be 1, 2, 3, 4th degree polynomial. And once again, it starts up and ends up based on the first page where it's even, starts up and ends up. Well, I hope that was helpful. I'm not going to go through this last one here. Yep, more